Okay, here we go. So the function smush takes a positive integer, or, well, it takes an integer. Really, I suppose it takes any number. It says float actually there. But it takes a number. If the number is positive, it returns the number divided by 2. So if I give it 10, it should give me back 5. If it's negative, it just returns the number. All right, so if I give it -7, it gives back -7. So let's follow the code. There's no trick to anything in computer science other than what does the code say. Line at a time, make no assumptions. If I'm in lab, if you come to office hours and I say, what does the code say? People always get all jumbled up going like, well, you know, the whole thing is, no. One line at a time, literally. One line at a time. I call on line 17, smush 10. That means the parameter a number gets the value what? 10. Hey, awesome, great. So then we jump down to line, it's kind of funny, I'm on an angle, line 10, and we just immediately say return value equals a number. Remember, a number is 10, so what value does return value get? 10, great. Then I ask the question, if a number is greater than 0, so we see the if statement, and then within that if statement, on that line, line 11, is that Boolean, the comparative operator, comparison operator that takes two numbers and it's going to give me back a Boolean. And it asks the question, is a number greater than 0? And a number is 10, we just said. So, is a number greater than 0? True. True. And everyone said true, so that's good. You didn't say yes, you didn't say yeah. It's true. Great. So, if true, whenever that condition is true, if it ever sees if true, we execute the code inside that if statement block. That's the code that's indented. There's only one line of code indented under that if. You can have as many as you want. This example has one. It says return value equals return value divided by 2. Well, return value has value what right now? 10. And then when I say return value divided by 2, what do I get? 5. Where does 5 go? Back into return value. So return value was 10, but we overwrote it with the value 5. Then we're done the if statement, and we see return value, it gives back 5. That assertion test is good because 5 does equal 5. Let's do it one more time with -10. I call it with -10. What value does a number have? That means on line 10, when I say return value equals a number, what value does return value have? Then I ask, if a number is greater than 0, is -10 greater than 0? So we don't run the code in the if statement. We skip all of those lines of code, and in this example, there's one line of code. So we skip this line, and we just jump down to this line, which says return value. What value does return value have? That means the function returns what value? Great. And that's what the test is looking for. Exactly, that's it. The if is, whenever it sees if true, I could hard code if true, and that's kind of silly because that code will always run. Similarly, if I put if false, it would never run. But we want it to be a condition worthwhile checking, right? So we put in some expression that's going to evaluate to a Boolean. In this case, it's what I'm looking for. Is it positive or negative? I just check if it's greater than 0. It's positive. If not, it's negative. Although 0 can go either way, but it doesn't matter. Because what's half of 0? 0. And if we're assuming it's positive. And what is 0 if we assume it's negative? Well, it's 0. Yes?
Differently or the same?
Like instead of saying return value, but just use a number, it would work exactly the same. So you know what, I'm going to do what I think you're asking, just so I can make sure, because it's actually a really good question. So obviously this way here. Okay, I run this, everything's good. But what you're saying is, just, you know what, why even have this whole return value thing here? Just say if a number, yeah, and then a number, like that. Is that what you're asking? Right, so if I run it, it's going to be just fine. This is A-okay, perfect. The reason I did it the other way is there is an argument to say, like, don't touch your parameters. If you want to play with the values that the parameters have, maybe take them and play around with them. But if you kind of leave them alone from like the parameter variable name, you're really safe. And this can come up a little bit later in the course when we start talking about something called references. This can have things that we call like side effects, which we're going to learn all about. So this is even hedging against a potential issue that could come up later. There would be nothing wrong with it here. This is perfectly safe, but because I'm being overly cautious, I did it that way. Great question, nonetheless. Other questions? Cool. All right, yeah. I just explained all of this. All right. You know what, we're going to skip this. Actually, yeah, let's skip this because, no, you know what? No, write this function is negative. Write a function is negative that returns true if a number is negative and false otherwise. I'll give you 2 minutes to do it. If you're stuck, use smush as a template and then change it to do what you need it to do. Is that easy to see at the back? Yeah, cool. If you're struggling, you're overthinking it. I guarantee. Raise your hand if you're done. Raise your hand if you'll be done in like 30 more seconds. All right, you got it. Okay, here's mine. And I wrote 3 assert tests. I checked a negative number, a positive number, and then I checked that edge case, that 0, because it's kind of in the middle. And you might ask, is 0 negative? Is it positive? It's kind of like neither. So if you made it so yours returns true, 0, okay. It's an ambiguous situation, right? Because 0 is kind of a funny one. I guess kind of the way I have it here, is 0 negative? No, but it's also not positive, so, but whatever. So who here wrote it like this or more or less like this? Great. Now, raise your hand and keep it up if you were in lab with me yesterday. Okay, now, keep your hand up if you wrote it basically identical to this. Okay, cool. So now I get to make fun of you, right? Remember the deal? So I get to make fun of you. So, for those of you that aren't or were not in lab yesterday, I took a moment to talk a little bit about this is 100% correct. There is nothing wrong with this. If you submitted this, you will get perfect, if this was the question, presumably. There is nothing wrong with this code, except all programmers will make fun of you for writing this code. And here's why. And it's not, I'm going to explain it, and it might not click right away as to why it's so funny. First of all, it's not funny. It's just we think it's funny. It might not click immediately why it's funny. If it does, great. If it doesn't, whatever. It'll come to you eventually. But let's take a moment and think about the execution of this program. I give it negative 10. It checks is some number less than 10. Is negative 10, or pardon me, some number less than 0. Is negative 10 less than 0? True, right? And so when that expression, that whole when that whole some number less than 0 evaluates to true, I return true. If I gave it positive 10, some number less than 0 would evaluate to false. So when that expression evaluates to false, we return false. Oh, wait. I never actually showed you else, did I?
So wouldn't it be easier to just put assert variable more than 0 and just put whatever?
Well, that would crash the program. So in some circumstances, you might want some sort of like exception thrown, but we'll talk about that idea way later in the course. Okay, I actually showed you something we didn't talk about yet in lecture, this else. So if you were stuck on this, you're normal. But so if true, it runs the code in the true block. If the thing evaluates to false, it runs the thing in the else block. It gives you that mutual exclusive execution. This or this, one or the other. If this evaluates to true, we return true. If it evaluates to false, we return false. So one might say, why even check the condition? Just return the result of this expression. If it's negative 10, what does some number less than 0 evaluate to? True. So then what gets returned? True. If it's positive 10, some number less than 0 evaluates to false. And then what would this function return? False. So it just cuts out the middleman. Instead of saying if true, return true. If it's false, return false. It just says return the true or false. Like, why check if it's true to return true and then false to return false? Just return the result. There's no need to do that check. Yes?
When you're writing the assert test, like on line 9, say, if you put like assert is negative 10, can you say equals true? Like, does it matter which order you
No, it doesn't. And in fact, honestly, I kind of would prefer it the other way. I just did it this way in the lecture content. But if you said, is negative 10 equals true, yeah, that's fine. Because it's all, usually the pattern when writing tests is you say expected, and then what's being evaluated. That's usually the order. But with assert tests, I kind of like to think of it as like function input, expected output, because it seems a little bit like it flows better to me. Either or is fine. Doesn't matter. Okay. All right, compound conditions. So remember, and works on statements that are true or false. If they're both true, then it returns true. If it's any other combination, it's always false. Similarly with or, but it's only when they're both false, it's false. All of the conditions, it's true. So I can ask multiple questions. I can have multiple conditions in that same line. I can say, if 3 divisible by 5, if a mod 3 equals 0 and a number mod 5 equals 0, then I return the string it is. 3 divisible by 5. Now, raise your hand if you know what mod is. I just said mod. Raise your hand if you have no idea what I'm talking about. Okay, you're normal. So, mod. I'm just going to jump here to show you an example. This percent sign is a new special operator. It's a new special operator. It's kind of like division. I mean, it does do division, but it gives you back only the remainder. So if I put in 10 mod 3, how many times can I take 3 out of 10? 3, right? You get 9. And then what's left over from the 10? 1. It gives me 1. 5. Say I put in 6. How many times can I get 6 out of 10? 1. And what's left over? 4. So it's a way to get a remainder. Now, how many times can I get 10 out of 10?
1.
What's the remainder?
0.
It becomes a really easy way to check if something is divisible by something. If something is perfectly divisible by 10, if I have, come on. If I had x mod 10, the result is 0 if x happens to be perfectly divisible by 10. Because that means there would be no remainder. Something divided by 10 with no remainder means it's perfectly divisible by 10. So that's how I'm using it here. If a number is divisible by 3, because its result is 0, and I'm also checking if it's divisible by 5 by checking if the result of that is 0, then I have this. So 3 divisible by 5. This is a function that wants to check, it'll take a number, and then it'll tell you if that number is evenly divisible by both 3 and 5. So I'm going to copy all this code and just run it so we can talk a little bit about it. So I put in 0. 0 is kind of a funny one, but is 0 easily divisible by 3 and 5? I mean, technically, but it's a weird one. 15 is, right? 15 you can divide by 5, you can divide by 3 easily, perfectly. Negative 30 is, negative numbers are weird. 3 isn't, right? Because sure, it's divisible by 3, but it's not divisible by 5. So this right here would evaluate to true, but this part would evaluate to false. And if you have true and false, that whole thing is false. They both have to be true. Negative 50, this would be false, but this is true. And 1 is neither as well. Great. Now notice how here I didn't have an else. Who here looked at this and was like, how come there's no else there? Okay, good question. Whenever a function hits a return statement, it immediately stops execution. Meaning, if this is true, this line of code will run, and then it immediately stops execution, meaning it can't possibly get to here. Now, there is an argument, a very good argument, that would be, you know what? You really should have your else there. The functionality is the same, only one will run. But just by virtue of the fact that return immediately stops the execution of the function, it's okay. But let me change this to a print to show you how this would react. So I run once, the first assertion fails, but we see it is a nope printed out. That's because if a number, so I put in 0. Is 0 mod 3 equals 0? Yeah. Is 0 mod 5 equals 0? Yeah. Then I print out it is. And then I'm done writing the code in the if statement, and then I return here to continue execution, and I see no. That's why we see it is no, which is kind of a problem because, well, that's not right. But because return ends the execution of the function right then and there, I know that if I go inside here, I can't possibly run this line of code. But if you're thinking, he should have had an else, you're right. I would say I should have an else here. I haven't talked about else officially, so I didn't include it here. Great. Okay, the module operator, sometimes called just mod, that's usually what I call it. Yes?
So then if you want to print it, you would use else, right?
Yes.
Okay.
Because else is what you would use if you want it to be like, you're either going to run this code or this code. It makes the execution mutually exclusive. Where the way I did it, it doesn't. It only just worked by a consequence of how return works. And you had a question too?
Yeah, just like how does it know to put no, like,
When I had it with the print?
no, like how is it just like assuming to put no if it's not is, like when you're not saying this?
Okay, so, because here's what happens. Let's say I put in 3. Okay, let's just follow the execution of the code. That's the only way this is good. We're going to figure this out. Is 3 mod 3 equal to 0?
Yes.
Who said yes? True, there you go. Is 3 mod 5 equal 0? False. Okay, so true and false evaluates to? So if false, well that means we skip the code inside here. We just skip the whole if block, and then we resume execution after that if block. Which happens because the if block's only 1 line long, it's just skip that 1 line effectively. That's why. Great question though. Alright, mod, yeah, I already just explained it. Alright, the above function uses and, right? So it evaluates this. And remember, Python never looks at this line and does all the number crunching in one shot. It doesn't work like that. It doesn't look at that whole piece of syntax and go, yep, it's true. No, it has to go in and evaluate each piece, just like we would if we were doing things by hand. I would say, okay, a number mod 3 equals 0, a number mod 5 equals 0. Well, I'd plug in the number, so let's say it was 15. 15 mod 3 equals 0, and 15 mod 5 equals 0. Well, 15 mod 3 is 0, and 15 mod 5 is 0, so we ended up with 0 equals equals 0, and 0 equals equals 0. We get true, and true, of course, evaluates to true. Great. So it doesn't ever evaluate all in one shot. It has to do it like step by step until it breaks it down into the final value that whole expression evaluates to. Similarly here, we put in 9, so we get 9 mod 3 equals 0, and 9 mod 5 equals 0, 0 equals 0, and 4 equals 0, true and false. Well, anything that's true and false, of course, is false. Great. So, alternative execution. This is a very common pattern. If x is greater than 10, do something. If not that, do something else. That one or the other. Right? That would be like, is it negative? Is it not negative? Right? Wait. I think I did a double negative there, but whatever. Let's move past that. This pattern is so common that we have a quick and easy syntax for it that I already showed you, else. These are the same. If x is greater than 0, and then x is not greater than 0, it would be the same thing as if x greater than, or I keep saying 0, I mean 10. X greater than 10. It's the same thing as saying is x greater than 10, otherwise something else. The else is a great way to make things mutually exclusive. We like this because it's easier to write, it's intuitive and easy to understand. I talked about this in lab with like 3 people yesterday. There's this thing that there's like a word we use in programming called like syntactical sugar. It's a weird word that all it means is we like our syntax to just be nice. Okay? It's great when we can have syntax, like we can write code to do something one long way and everything. But if we can have syntax that just is a little bit more intuitive and clean and more human friendly, we like that. So we call that like syntactic sugar. So this is like a simple, easy example of that. Else is a lot nicer to write than like not the expression I just evaluated, right? It's a little nicer. And it's easier because it can eliminate bugs. Imagine having this and then you're like, oh, I need to change the condition. And then you change it to like greater than or equal to here, but you forgot to check it here, and next thing you know, you're in trouble. All right. Activity, yeah, another activity. Write a function called hail that takes an integer as an argument. If the integer is even, return the value of that integer divided by 2. If it's odd, return the value multiplied by 3 and with 1 added. In other words, given a number n, return n divided by 2 when it's even and 3n plus 1 when it's odd. Don't forget about mod. How do you check if something's even? Is it divisible by 2? Big hint. I'll give you 3 minutes for this one. It said it was going to be an int, so. Raise your hand if you're done. Raise your hand if you'll be done in like just one more minute. Okay, take the minute. Does anyone recognize this thing I'm showing you? You do?
Yeah.
You do? Yeah. What can you tell me about it?
It was a caddis problem, almost.
Oh, okay. Oh, you're right. Oh,
That's
that's
what I was thinking as well.
okay. Because it's actually even more famous than that.
The 3m plus 1, the thing that goes on forever.
Well, so this is a special function where it's like, does it ever converge? Meaning, if you like plug a number into this function, get the result, and then plug that result back into the function, and just do that over and over and over, does it ever converge? And so it's kind of like it's a funny little thing. I might be remembering the details wrong exactly. Hopefully not too wrong, but that's the idea.
Yeah. But yeah, I do remember this was on like the caddis yesterday.
Cool. All right, so. Line 2.
Should we always put type hints in it or?
Type hints?
Yeah.
Yes.
Okay.
If I don't, it's because I'm being lazy and I'm
No.
trying to move quick. Just like how this is a terrible doc string.
Is there like a format for the, like I know there's some format for the doc strings there, like param and like R type at the bottom and stuff, but like for what the message you actually write, does it have to be like super professional?
Just-
or-
Make it as nice as you can,
Yeah.
but there's no hard
Like,
rules. Like
will we
explain
get
what the
graded
function
on that
does.
kind of, or not really?
Pardon?
Will we get graded on that part so much or not really?
You could if they're really bad lose marks.
Yeah. Okay.
So the marks for that are like there's discretionary marks where it's like okay
Yeah.
everything's right but your comments suck so you lose a mark.
Yeah, just descriptive enough, I guess.
Yeah. Times 3. Okay. Which is 4.
Negative 14.
Thank you. I was thinking like, whoa, uh-oh, do I? Good catch. So here wrote something basically identical to this. Raise your hand. Did anyone write it a little differently? I'm curious. You did? How'd you do it?
Just a little bit more steps is all.
Oh, okay, cool. That's good. I mean, we could have done what we did in that other example where I don't have the else, but again, we should have the else. Technically, this would work without it. Some people start like that, and you would say, some people might argue it's better to do it this way. Did anyone do it this way? Does anyone not even see what the difference is? Okay, well, that's good.
No, I
You did it this way? So some people, and this is not a rule you need to follow. It's not even a convention. It's just there are some people that argue, your functions should only have one possible exit spot, right? So only one return line, right? So instead of having the 2 return lines where you just return when it's done, they would say, well, no, like assign the value, and then when you're done, return the value. There's an argument for that. It doesn't matter. Yeah.
Is that necessary to set return value to 0 at the start?
Let's see what happens if we don't. Okay, we're okay. Some IDEs might give you a warning saying like, oh, are you sure that that variable was ever initialized? Where here we would know, well, there's an if and else, meaning one of those two lines have to run, meaning that variable return value has to be set. But in other programming languages, though, something like this would not like work at all. So it's just a consequence of being programming for a while in different languages. Yes?
If you make your code with more steps, will you get dolled for not making it as simple?
No, not at all. Not at all. There's very, what time is it? Well, we're running out of time. But, do I have a, when we get down here, we'll take a little bit of time to talk about what it means for a program to be efficient versus inefficient. More lines of code is not less efficient. There's no necessity there. In fact, a lot of like when your computer finally does do all the number crunching, the computer might actually change your code so it's even a little tighter. But yeah, there's no, yeah, that's A-okay. Okay, here's Smush version 2 where I did it with an else, which is what I did the first time. But I could have done it without the else and it would work just fine. Oh, and see here, I didn't even set return value at the start. Ooh, like you just asked, right? So there you go. Smush version 3. Ah, okay, so here I have the 1 return and then here I have the 2 returns. They are all valid. Point being, we don't even need to get into that complex of problems to solve where you can start to see how code can differ enough that you're like, yeah, okay, I can kind of see how there are multiple ways to solve the same problem. This, where the difference in code solving the same problem is only going to get more drastic as we go and add more complexity. People always think like, well, I got the right answer. Isn't our code going to be the same? Chances are no. It's very unlikely. Unless it's like a 3-line function, okay. But things will start to differ quite a bit as we go. And it's kind of interesting to see the differences, but they're all right. I mean, these ones here, the algorithms are effectively the same. They're doing the same thing, but they're written differently, which is interesting. Okay, exclusive alternatives. If I have something like this, if, right? And I type in, you know what, here. Letter grade broken. And I give it a 95, right? Based on this, their grade should be 95, right? I hit run. I see a D. That doesn't make any sense, but it does. Because what's the one trick? What does the code say? So, I put in the value 95. Percent grade has what value? 95. Okay, then I start with letter grade starting as just an empty string, a string with nothing in it, just an open and close immediately. And then I say, percent grade, which is 95, is percent grade greater than or equal to 90? True, great. So letter grade is set to A+, great. Then I jump down to the next thing. If percent grade is greater than or equal to 80, is 95 greater than or equal to 80? True. All right, great. So letter grade is now A. Is 95 greater than or equal to 70? True. So it's a B now. Is it greater than or equal to 60? True. Yeah. All right, so now it's C. Is it greater than or equal to 50? True. True. Okay, so letter grade's now D. And then we've got this else, but we ran this if, so we could skip the else. I return letter grade, we see D. The problem here is each if statement got run independently. But really, I didn't want them to run independently. they kind of go together. They're actually cohesive in what they're meaning. I want this to run such that only one will run. I want them to be mutually exclusive. Now, I saw people in the lab do things like, okay, if, else, and then in that else there was another if, and then else, and then another if. That works. But we have more syntactical sugar, where we have this fancy, here's me explaining what's wrong with it, where we do elif. If you put elif, which means else if, it turns these statements into mutually exclusive ones. So if I say percent grade is 95, true, letter grade's A+, only one runs, it skips all the others and jumps down to the return. Great. Well, I'll say this again on whatever day, Tuesday.